Dr. C. Rajakumar completed his PhD under Faculty of Information and Communication Engineering in Anna University, Chennai. ME Computer Science in Science and MCA in Madurai Kamaraj University. He has 17 years of total experience, including teaching and industry. Extensive experience in object-oriented design and development, Java, J2E, middleware, enterprise application architecture and implementation. Hands-on experience in delivering valuable insights through data analytics and advanced data-driven methods. Proficient in building statistical models with R and Python. Experienced in analyzing and understanding the vague requirement and dynamic enough to provide solutions to the faster changing requirement. He is very agile to quickly learn and adapt to new technologies and world of knowledge in the development and implementation of educational tools and applications. With this small introduction, I hand over the session to Dr. C. Rajakumar. Welcome, sir.
Yeah, thank you, ma'am.
Thank you, sir.
Thanks for the very elaborate introduction, ma'am.
Thank you.
Very good afternoon to everyone. I guess you are able to see the screen, I guess. Please confirm, anybody? Ma'am,
no, sir. Your screen is not visible actually. Welcome slide only there.
Okay, it's like a first slide. It says Department of Biomedical Engineering welcomes to you all. That's a slide, ma'am. Is it?
Okay, sir. Okay, sir.
Yeah.
It's visible only, sir.
Okay, ma'am. Okay. Yeah. Today's topic is in this timing we are going to discuss the topic like detecting the pneumonia from the medical image data by using the machine learning techniques. And that's a topic we are going to discuss. So in that, initially, I would like to talk about medical image. Later, I would like to talk about machine learning, and then detecting the pneumonia. That's a key term we are going to discuss in this session. And so already, ma'am tell about my details. Even I would like to tell about little bit more about that. So I started my career as a lecturer in RVS Engineering College. Then I moved to IT industry, and now I am a technical architect in Textract Technology. And this is an agenda we are going to discuss. So first thing, as I said earlier, we are going to discuss about medical image related things. It's like an introduction level. And then we are moving to machine learning process. It's like what I understand a different heterogeneous audience are there here. That's why I would like to introduce machine learning in a high level. Then detecting the pneumonia by using a machine learning techniques we are going to discuss. And I try to cover a hands-on session for that at the end of the session. And finally, I would like to summarize the topics what we are going to discuss. And the prerequisites for the session is technically people you need to know Python 3 basis, and non-technically everybody needs to listen eagerly and eager to learn new things, and you should ask questions in between a session and no need to wait for the end of the session. And the main thing is like don't feel sleep, because this is an afternoon session, right? So after your lunch, if you listening a session or even listening a music also you feel sleepy. So these are the requirements you need to know to understand this entire concept. And first I'm moving to the introduction about medical imaging. Medical imaging is nothing but a set of processes, or we say like a techniques to create a visual representation of the internal parts of the body. This is for purely clinical purpose. The main purpose is to monitor our health. Based on that, a diagnosis takes place, and the treatment related to the disease or injuries will be happened after that. Also, it helps to create a database. Okay, in this has happened earlier in US. They created everything as a digital image. Like that, recent days, even India also are doing the same thing. All the data, especially a medical data, is stored in a database. The database is for further purpose. That may be for research. That may be for further analysis. So that is also important help from medical imaging. Three types of end users are there in medical imaging. Patients are the main key player in that medical imaging, and the doctors again play a vital role, because based on the patient's information, patient's data, they directed the particular disease or illness what happened in for them. And another category of people is like computer vision researchers. So CV, computer vision is one of the dominant area in research, which do a lot of image relating activities. And medical imaging have lot of techniques. Simply we say it have different type of techniques it has. Due to the different type of or different categories of technology, it provide different informations. And even though every it changes each and every day, lot of things are happened each and every day in this particular domain. uh, why? Because a lot of advancements are happened in that. New advancements will be happened in computer vision. At the same time, the technology what currently is used is improved day by day. Even manufacturers, lot of manufacturers investing a huge money in that field. Why? Because this provide a huge what impact in their earnings. Say for example, Fujifilm, GE, Siemens, Philips, those companies are providing at the same time of investing a lot of money in that area. Yeah, I guess few of them peoples are in this audience knows about this, like medical imaging techniques and its types are there. Very basic and everybody knows technology is called radiography. This is nothing but we are taking an X-ray frequently, right? That's the thing. So X-ray beam will be used for doing that. This is one of the first imaging technique, even in modern days medicine also. And the next one is called the MRI. Again, we know about that MRI scans, everything. This is better than CT scan. Why? Because the radiation usage is not here in MRI. Again, it provides some images in digital form. Another technique is called ultrasound, where high frequency broadband wavelength that will be used to create what? That will be used to create a 3D image, which is mainly used for identifying the function of moving structures in a real time. And without any emitting ionic radiations, this technologies work. Because of that, this is very safe, and it quickly perform without any side effects. It's relatively inexpensive. And one more technology is called endoscopy. Even this is also everybody know about that. So it helps to examine the hollow organs or a cavity of the body. Like that, thermography is also there. In that, camera is used to detect the long infrared radiation emitted portion of the body, and it create thermal image. Based on the thermal image, the further analysis is done by the doctors. Like that, lot more medical imaging technologies are there, especially nuclear medical imaging and the tomography. Those things are coming under medical imaging technology. So all the things providing a lot of images. Those images are stored in a hard disk, or simply we say a storage, that may be in cloud or that may be in servers. That's why medical imaging is important nowadays. So even though it have a lot of important points as why this is needed nowadays. With the help of these medical images, we can easily diagnosis the issue, and the early diagnosis is also possible. Due to that, surgical investments can be avoided sometimes. Okay. At the same time, health informations can be available from time to time easily. That means information about a particular patients, accessed from anywhere and anytime. Think about that, a patient history which is in US, that is able to access from India at any time. That may be in the midnight or that may be in the early morning. And it helps to diagnose the illnesses like pneumonia, cancer, internal bleedings, or injuries in brain, those kind of a thing. And early detections definitely empower the doctors, at the same time the patients. That's why this medical imaging is very important nowadays. And I'm moving to machine learning process, how it going to be support in healthcare industry. That's a new topic. That's an important topic we are discussing, going to discuss now. And this is, before entering to that machine learning, I would like to discuss about general learning. Okay. So general learning is nothing but, normally from our childhood days we learn a lot, right? Think about that, with the help of our parents and relatives, we learn a lot of good things, and we learn about what is a good and what is a bad, right? For example, taking a bath is a good thing for us, and brushing a teeth is a good thing, and playing with the fire is a bad thing. So these things we identified, we learn from our parents, from our surroundings, simply I say. So like that, if suppose nowadays, if suppose somebody doing things as like, like they are doing mobile usage in the late night, automatically our brain says that this is nothing but a bad idea. Okay, this is bad. So like that, if somebody taking carrot frequently, your brain tell about that, that is a good. How this categorization happened in our brain means, because our brain learn a lot about the goods and good things and then bad things. So this is a learning happened in a human, right? Like that, the learning is happened in healthcare sector also. So normally doctors doing this practice with the help of data which is collected from numerous patients. So in one particular time, the doctor become an expert. Why? Because he has a lot of data. Based on that data, he become an expert in that particular field. So like that, machine learning is nothing but a program. Simply we say a machine learning algorithm, which is going to learn from the historical data. So the historical data means data stored in a medium. The data may be in different form. Sometimes that may be an image, that may be a video, sometimes that may be audio. So based on that, a program understand, learn the things as, then it create a model. That model is called, we say normally in machine learning term, we say like that is called predictive model. Okay. So if a predictive model is built by the machine learning algorithm, then that is ready to do the predictions. So if a new data is come, predictive model already have the knowledge about the particular data. That data will be identified and that predicts the output. This is the way machine learning works. So we need to give data to the model for training, and later the model understand with the new data and it predicts the output. Best example for machine learning is, if suppose you are searching text stack technology in Google Map. So we are able to do the direction, right? So from bus stand, Dindigul bus stand to tech stack, from Dindigul bus stand, if anybody wants to reach tech stack technology, it gives three options basically. So how this is work means, internally Google Map is a program. The program have a model. The model analyze all the picking spots. Okay, it have route details, It have the informations which is related to the pathway of the particular route, and the distance about that. Based on the distance, it able to calculate the travel time. So those things are happened behind the scene. So this is the best example for machine learning. Currently, we are using everybody while we are doing travel for the unknown places. We are using a machine learning kind of a thing using Google Map. So like that in medical industry. So how the machine learning is going to help for us? The basic thing is artificial intelligence is a huge term. It's a broad umbrella term. Inside that, machine learning is come into play, and it helps the healthcare industry towards easy and accurate diagnosis. And it has the ability to process huge volume of data, which is not done by a human being normally. So we have some capability, right? We are not doing we are not able to process the huge volume of information what is available in a hospital, but the program have the capability, it able to process the data. At the same time, this is reliable. It converts the analytical informations which is done by the program into clinical insights. And even it gives the better outcome also with the low cost. And it increases it increase the patient satisfaction. Why? Because of the accuracy. At the same time, yearly diagnosis. And other applications also available related to machine learning term in healthcare sector. Those things are called data collection and follow-ups. This is nothing but lot of apps are available nowadays which collects our health data. So it gives the follow-ups based on that. And drug discovery and development is another area where new drugs will be identified based on the requirement of the requirement for a disease. One more thing is like robotic surgical tools. In US, this is implemented. Even UK is also this is implemented. Yeah, surgery is done by robot arms, which is well programmed. It do a perfect cuts and a perfect surgery based on its learning. So many more things are available in healthcare sector related to machine learning. So those machine learning techniques have a lot of algorithms. Those things are categorized into 4 different way. Those things are called supervised, unsupervised, semi-supervised, and reinforcement learning. So I'm not going to cover everything here. Our demo is based on KNN, K nearest neighbor. Supervised learning again have 2 different classes. One is called classification, another one is regression. And unsupervised, we have the categories like clustering and dimensionality reduction and an association rule mining kind of a thing. So a lot more algorithms will be there in nowadays. Even deep learning is also one of the new things comes into the umbrella, under the umbrella of AI, artificial intelligence. It have its own learning techniques and algorithms. And why machine learning over traditional approach? Here, the traditional approach is nothing but a clinical doctor, basically a radiologist, able to read the images which is given by the medical imaging technology, right? But why machine learning play the role instead of them means lot of challenges come into the new world, especially for the experts in the medical field, because the image which is given by medical imaging technology that needs to be interpreted properly. So quite limited experts are there in the world. Why? Because of the complexity. And even nowadays variety of parameters are comes into the picture. The images, especially in images, lot of parameters are analyzed. Those things needs to be understand, and that those needs to be well articulated by the doctor. At the same time, patient to patient data is vary. So the data which is provided by medical imaging technique is different. That's the reason machine learning going to come instead of a traditional approach. That is one of the challenge. Another challenge is, different, as I said earlier, little bit earlier, like different medical imaging techniques will be there. So this is because of the rapid growth in medical imaging acquisition process. So huge volume of data is available in one end, a very limited number of expert, especially medical doctors are there in another end. So how those experts are able to process the entire things is that's a big burden nowadays because of the huge volume of data. Due to that, what happened is the probability of human error is also increased. Sometimes the experts may do some mistakes in their analysis, but machine not doing that mistakes, right? If we properly done a program. So this is another challenge which is available. That's why machine learning comes into the picture. And that thing is like, we are a little bit deep dive about a healthcare process. One of the challenges like pneumonia detection. Sorry, 1 minute. Yeah. How the lung will be infected. So those things needs to be analyzed properly. Sometimes the lung may be infected by virus, or that may be by bacteria, or that may be fungi or any other pathogens. Okay. So those things needs to be determined properly, whether that is a patient is suffered from pneumonia or not. So this is treated like a binary classification problem. Why? Because it gives only two output. So a person may be pneumonia positive, or a person may be pneumonia negative, like that. So if yes means it determines whether the cause is done by because of the bacteria or virus, those kind of a further analysis needed. So this is another challenge. So the starting point is one thing, whether the person is affected by pneumonia or not. The later point that goes into deeper. So lot of parameters are there to analyze that. As I said earlier, like experts are very less to analyze the uh, data which is available in the world. And this is the overall process normally happen in machine learning side. We'll have an algorithm called machine learning algorithm. There are two phases available in that. One phase is called the training phase, another is called the testing phase. In the training phase, what happened is we are giving a data. The data is called training data. So the data is given to machine learning algorithm. Based on that training data, a machine learning algorithm create a model. That model will be tested with the help of a testing data. So basically do the prediction and give the result. Parallelly, we need to do a model evaluation process. If the model give a good accuracy, that's okay. If it is not, again, the further tuning is happened in machine learning algorithm, and again, it gives another model. So if a model gives a good accuracy, we stop in that. If it is not, again, this is like what repeated process we are doing that. Once it meets the expectation, the model is fitted for any kind of a, prediction process. So this is the overall picture about machine learning techniques. So up to now, any doubts? If you have any doubts, please ask me a question. Please do not wait for the end of the session. Okay. And now we are going to talk about detecting pneumonia by using a machine learning technique. So up to now, what we done is we are discussing about introduction about what like medical imaging, and we are discussing the introduction about machine learning. Those things are in a very high level only. We are doing that because in a given time, I would like to give a good picture to you for about the particular technology. So now we are entering into this detection process. So how the detection process is executed means um, uh, pneumonia is identified overall in the entire world. To detect a pneumonia, X-ray image is a better thing instead of MRI, or instead of what we say like ultrasound. And this thing is very easier process. So the input for the machine learning model is X-ray image, which is in a digital form normally. It gives an output. Simply, it gives an output. The output is nothing but pneumonia positive or pneumonia negative. This is the entire execution process. Okay. So for that, what happened is the image will be interpreted. by the program in this way. Okay, what kind of a way means the image is treated like a grayscale images. Definitely, this is like a grayscale image, right? The image given by a X-ray machine, like a radiological machine, is an grayscale information only. Each and every pixels in that image is treated in this way, like some of the things are dark, some of things are bright. Okay, so basically image have values between 0 to 255. 0 means dark, 255 means white. So here, a pictorial representation of grayscale will be there. If a particular pixel is 0 means what is the meaning? That is called dark. Okay, if a pixel have the value like 255 means it is what, it is in white shape. So from this X-ray, which image which we have earlier, be above the scale, grayscale, we are able to identify 5 different areas. One of the thing is darker area. Normally, how this will be interpreted by the program is, it is basically a area which is filled by air. That's the thing, darker area. And dark gray, this is nothing but a tissue, that may be a tissue or fat. In that way, program interpret the particular portion. If it is lighter gray, it says or it thinks about the portion is a soft tissue, or that may be like soft tissue organs like a heart or blood vessels. And if it is off-white, it understands it's a bone, such as a ribs kind of a thing. And if it's a bright white, that may be some objects like a pacemaker kind of a thing. This same kind of knowledge is available for the doctor. The doctor doing that kind of what practice happened in his earlier days. So based on their knowledge, he predict the thing, right? Like that, a particular image will be interpreted by the program in this way. So if a lung is suffered from pneumonia, that means what means normally what happened is the air dense lungs will be filled with the water dense. It is converted as water dense lungs. So definitely there is a difference, right? Yeah, fading is happened in the demarcations lines. So pixel density will be varied here. So based on that grayscale bar, a program able to understand what happened inside the lungs. Okay, that's the overall process, how the interpretation is happened in the programming level. Okay, this is going to be done with the help of a hands-on. Uh, um, so before entering to the hands-on, I would like to talk about data set, what we are going to use here. Okay, the data set is nothing but Kaggle provide a lot of data. One of the data is called chest X-ray images. Okay, in the particular link, so I provided the link where we have a lot of images. Totally, it provides 5,863 images. All are in JPEG format, which is in 2 different categories. So some of the things are coming under pneumonia category, some of the things are coming under normal category. Okay, so we are using this data set for the demo purpose. Why? Because we don't have a real-time data set, right? To build a machine learning model or a deep learning model, this is normally happened. So earlier days data will be used for the practicing purpose, or we say like a training purpose. Later that will be tested with the help of real-time data, which is getted from the patients. So this is the data set area where we are getting the data. I have a local repository where this data will be stored. And to do the things is in Python, especially this machine learning process, we're able to do in Java also, but preferably these machine learning techniques and machine learning algorithm executions are done in Python. At the same time, R is another language. Using R language also, we are able to do that. But here our practice is with the help of Python only. To do that, lot of libraries we need to import in our location. One of the libraries is called a NumPy, and this is for providing a data structure. Especially, it provides n-dimensional array. Okay, with the help of because the image needs to be stored in n-dimensional arrays, right? And then that's the purpose we are going to use this library. And another library is called pandas, which provide complex data structures and functions on top of that, which also helps to do a lot of analysis kind of a thing. And matplotlib is for plotting the images, and it provides visualizations and kind of a thing in 2D format only. And a Seaborn, that is another library which is for statistical data visualization process. The main library is called OpenCV, which is for reading an image and analyze the image it uses for us. And another thing to do the machine learning in Python, scikit-learn is another library which help us to do the classification, clustering, regression kind of things. So these are the libraries I'm going to import in the working area. And already I said the chest X-ray, which is available in Kaggle, those things will be connected here with the help of this library. So we done the process like training, testing, and evaluation process. And how this kind of a thing will be executed means definitely we need an environment, right? So to do this kind of a Python program, the best environment is a collaborator, which is provided by Google. So simply we say Colab. This is for research purpose. Google provide this environment. No need in install anything. Okay, just you can use that environment. That's why I put the point like zero configuration is required. Just if you have a Google account, that's it. With the help of that Google account, you are able to access this environment. And with the free of cost, you are able to access a GPU processors, graphical processing unit. Like normally we are using CPUs, right? So heavy weighted images, those things are accessed with the help of GPU processors only. This is very costlier, but Google provide with the free of access for it. At the same time, sharing a code between members in Google is easier here with the help of this environment. Okay, so now we are going to do that machine learning process. The execution steps are this one. We are going to do a step-by-step process. So please be patient to do this all the things. Why? Because we are going to load the entire image, right? Nearly 5,335 images will be there. Those things we are going to do that. So sometimes there may be a delay for the execution of the thing. So please wait for that. And at the same time, once the images will be loaded, the images are going to be understood. Okay, so what kind of image is there, and to understand the particular image, we need to visualize it, right? After that, analyzing various important aspect of image is done with the help of some parameters like a grayscale kind of a thing. And if needed, we will do the pre-processing step. And then after that, you are ready to do the model building process. Further data needs to be splitted, right? So the splitting is happened in two different things. One is called the training and then testing. And to build the model here, we are focusing on k nearest neighbor only. Then we are doing the prediction. Then finally we are going to do that evaluating the model. Okay, how the model will be evaluated, how that identifies the model, how it behaves like that. Okay, that is called evaluation. Okay, so I'm going to that environment. uh, are you able to see the screen now, which is related to collab? Please confirm. I moved that from the presentation to the next screen. Are you able to? I'm not hearing you properly. Anybody please help me? Are you able to see that screen?
Sir,
Ma'am, are you able to see the collaborator screen?
no, sir, no, sir. Only that ML model execution step is there.
Okay, ma'am. Okay, I will do one thing like stop sharing, ma'am. Okay, ma'am. I will do the stop sharing, and then again I am sharing the screen.
Okay, sir. Okay, sir.
I guess now we are able to see, I guess. Ma'am, is
Yes,
it?
sir. Yes, sir.
Oh,
It is visible, sir.
okay, ma'am. Thanks a lot. Thanks a lot, ma'am. Here, Kaggle, I told you, right? Kaggle.com, where I get the record, which is like images, chest X-ray images. Uh, 1 minute. Okay, so this is a chest X-ray images. Here, the size of the image is 2 GB, total size of image. Okay, nearly 5,800 plus images are there, right? Which is in two category. The total sizes for the data is 2 GB. So that 2 GB data is going to be processed with the help of Colab environment. Okay, so this is a detail about all the things, how that will be categorized kind of a thing. If I enter into the training folder, it loads the data which is available under training. Okay, it again, it categorized into two. One is normal, another one is called pneumonia. Okay, here you see lot of images will be loaded here. Okay, so this environment provided data, Kaggle provided data for us. Okay, I'm closing that now, no need for us. And Colab, I tell you about that. If you search in Google like Colab dot research dot google.com, you are able to get an environment. The thing what you need is just you need what a Google ID, that's it. Okay, so I'm able to create a new notebook here. Here you can do what kind of whatever you can do in Python. Okay, this is an environment for doing a Python program. And just the environment is different. I'm not installing anything here, right? Just you can play with the Python here. Whatever needed, that needs to be imported definitely, but no need to install it. The software, no need to install any software for this. Okay, that's the point here. And here for simple purpose, simple sake purpose, I will do that like what, like session equal what I can say like a Sttp. Okay, and if I do print of session, then if I'm doing execute is nothing but the play button, it executes. Okay, so this is the process it shows, right? If it stops, then that means the program is completed. Okay, the execution is complete. Here is it prints HTTP. The normal arithmetic process I will do. Instead of this place, I'm going to add one more code here. This is for just an introduction about Colab environment. If I say normal arithmetic operation, I'm going to do maybe 100 and b equal to 5. I'm going to do multiplication a star b. Okay, if I'm executing, we're expecting 500, right? So it prints as 500. So like that way we can do our Python stuff here without doing any kind of a configurations. Okay, maybe I can say like this, session star 5. Okay, session star 5. You do the expression, right? You do, it prints HTTP for 5 times, right? So this is the environment which is for doing Python programs. Okay, it provides a lot of stuffs in that. Okay, here I'm done that program, which is already done because step by this is a huge program, unable to do a step-by-step process, right? I will explain it what it does. Here, I'm importing lot of libraries. Already I said the NumPy. This is one of the thing for providing a n-dimensional array, right? And matplotlib. This is for doing two-dimensional like diagrams. Simply we say graphs. Okay, and this is for OS. This is for accessing the drive. Here, how I'm doing is I loaded the Google's images to my Google Drive, where I can get all these informations. Okay, and the CV2, this is for image reading, and this is for random output generation purpose. Okay, we are not going to use all the data for training. So we have some proportions. Normally 80-20 proportions are used. So 80% of data is going to use as used for training purpose. 20% is used for testing purpose. Like that normally happen. For the random selections, we are using this package. And here I'm getting my content from Google Drive. So G Drive here, this is a Google G Drive, Google Drive. So where the data is available here. Okay, so I'm changing to the directory now where the data is available. Give me a minute. So I need to 1 minute. I need to restart the runtime because this is started earlier. Okay, now the session time is out. That's the reason the problem is coming. I'm doing the process again. I'm connecting my Google Drive. That's nothing but a mounted to the Google Drive, and I imported the OS package. With the help of that, I'm accessing my drive. Now I'm going to change my location. Now this is changed, right? And what I can do, like I'm checking the current directory with the help of the command pwd. I can check it for. Okay, now this is under Kaggle. Here, we are able to access the same folders here. G drive, this is in my Google Drive, where my drive is one of the folder. Inside that I have a lot of folders. One of the folder is called Kaggle. So inside the Kaggle here, you have a lot of images will be there, right? Chest X-ray. Here the images will be there. These things will be used for our practice purpose. Okay, normal category will be there. At the same time, pneumonia category is also there. Okay, here images, a lot of images will be there. Okay, so now this is in my environment. The data is in my environment, which is fetched from Kaggle. Okay, so I define a function for loading the data. So I'm doing that by running this program. And another thing is like loading a single image. I need a program. Simply we say function, which is also I am done that. And read the data. I am writing one more function which reads the data in two different category, normal and then pneumonia, right? So finally it gives the image details in detail. Okay, so basically here what I'm doing is I'm reading the data in two different fields. One of the reading is like training data, another one is in the format of testing data. Okay, so if I'm accessing a training, I got the training data only. If I'm accessing testing, it gives only a testing data only. Okay, so this is executing. It takes some time. Why? Because it do all the image processes, right? Around 5,000 plus images are there, right? It takes a little time. This is executed by Google's CPU. Here you see it uses the RAM and then disk of Google. This is not related to my environment. Okay, my machine's CPU or RAM. Just we are using our browser to execute this program. Okay, just internet access is needed. So the broadbanded network is needed to do this process. That's it. No need to install any kind of a program. Okay, and next thing is once this is completed, we are moving to the next. Here what happened is randomly we are choosing a training image and then test image. Okay, some 10 images from training, 10 images from testing. So some of the things may be normal, some of the things may be pneumonia related images. Okay, those things we are going to analyze it. So we loaded the data. We completed the step like loaded the data. We are going to do the analysis. For doing the analysis, we split the data into training set and then test set. Okay. Give me some time to do this for the completion of this process. Up to now, do you have any other doubts? If it is not an issue, I will move further. Now this process is completed. Here, I am doing a shuffling process. For that, I'm using that a random package. And the pandas I'm using here for what? Like a data frame creation. I've created the data frame. So just for understanding purpose, I am seeing the data here. It lists out the data for me. So it lists out the categories of things as okay. So if I'm shuffling again, the data will be changed. Here, all the things are pneumonia related, right? If I'm running this again, here, it splits into 5 different category. Okay, the first five, we hear what is the output here means. It shows the first five records, okay, which is in training. If I want to do the testing, okay, I can create one more data here for testing. Just I'm copying this code and then pasted it. But we need to change the, instead of train, I need to do the test, right? Test df. Okay, if I'm running this, it lists out first five records. Okay, so first record have a detail about pneumonia. Detail about means it carries out the image, right? X-ray image which is affected by pneumonia. Second is also affected by pneumonia. This is normal, this is normal, this is also normal. Normal means the patient is not affected by pneumonia. So the X-ray image is clear. Here the X-ray images have some kind of a grayscale informations because of the affection of because of the impact of pneumonia. Okay, and this is the way we are going to analyze the data. Okay, how what the data is. We need to understand the data, right? So we got the data from Kaggle. The understanding of the data is done by this way. To do the understanding, pandas is needed. Panda library is needed. Okay, and I'm going to use Seaborn, that is another package for giving the pictorial informations. Okay, I will do that. Here, it gives a lot of information to us. I will maximize this output. Okay, then you can understand a little more. So full screen, I will make it as a full screen here. So we have a training data as well as a test data. Okay, training data have normal cases up to around 1500, and the pneumonia cases it have up to around what, like 4000 cases. Okay, in a test data, pneumonia is have around 400, and normal is around 200 to 2000, sorry, 250. Okay, so this kind of a pictorial representation is given by Seaborn. Seaborn is one of the package which is in Python, which gives this kind of a detail. Okay, how your data is balanced. This kind of a training data is used for our model training, and this is a data which is for testing. Okay, this is for testing. And to load a single image, I need a load image method, and to show the particular image, I need this kind of a function. This is written already. I defined already. Show example images, which gives what, like a 5x5 kind of image structures. I will maximize it. Give me a minute here. Some of the samples are read from that repository. Here, some of the things are normal, some of the things are affected with the pneumonia. If you saw this picture, we don't understand it, right? Because we do not have that information about that. But the persons, especially the radiologists, able to understand. Okay, now we are giving that role to our machine learning model, right? For that we are writing all these steps. So up to now we just see the data how it is. Okay, this is one of a detailed information about the image. This is like a prediction. Okay, we are doing what, analyzing the image with the help of a grayscale. I will maximize that particular screen. Here you see it gives the dimension of the image, at the same time maximum pixels, minimum pixels, mean value for the pixels, standard deviation. Here it gives grayscale, right? So these are the informations needed for that algorithm to understand whether the lung will be affected with pneumonia or not. Okay, and I am moving to next piece of code. The same image will be treated as a histogram to understand further. Here, this is one of the diagram which tell about the histogram of an image. here, the plot will be there, right? So here a huge dense of pixels will be there instead of here. If I'm comparing the edge of the graph, this portion is have a huge pixels, right? So this kind of analysis is needed for that algorithm, and this is a manual analysis we are done, but the same kind of a process is done by our machine learning algorithm. So now, up to now, we understand that data, we explore our data, how it will be there, and we splitted the data for practicing purpose. That means a training purpose. So I'm going to create a machine learning algorithm now, which is based on k nearest neighbor. For that, we have a package called scikit-learn. Okay, I'm loading that. Even TensorFlow is also used in this example. For that, I have defined multiple methods like metadata getting process, data splitting process, everything. It loads internally. It loads a lot of libraries like a kaiser kind of a thing. Okay, so once this will be executed, I'm going to get the metadata about that. It gives a little bit more information. Okay, here now the data is splitted, right? Some of the things are training, some of the things are testing, but here it displays first five things is maybe last five things if we need means metadata dot file. Tail of that is one of the method which gives last five records. Okay, here you see this is last five records. This is also coming under test category. Its index value at the same time. This is a class detail. If it is one point, this is a floating point value. If it is 1.0 means this is affected with pneumonia. This case is affected with pneumonia. If it is 0.0 means this is normal. Okay, this is the prediction. For this we are done this coding practice, and the training testing data will be properly allocated with the train data and then image kind of variables. As now we are going to execute the KNN model. Okay, so we are using k nearest neighbor classifier with 10 neighbors. Okay, k value is 10 here. We can change this value for evaluation purpose. If I give 5, it may vary, and the performance of the model may be vary. If I give 1, that may be vary. If I give more than 10, that may be vary. So which one is best fit, we need to identify. Based on that, we will stop our process. Okay, here it gives a lot of details. 1 minute, I will show you and the entire thing. I will maximize it, then you can easily understand. Okay, which is coming under black screen. Better I will minimize it. Here 0.7175. This is the score, accuracy score. Okay, here I am printed that. So accuracy of this model is approximately 70%. Okay, and the KNN prediction is it predicts like pneumonia positive for the first 3 cases, and for the fourth case it identifies pneumonia negative. The remaining things are like a positive. So this is the way to it predicts, right? This is a binary classifier, as I said earlier. So it gives only any one of output, like that may be a pneumonia positive or that may be a pneumonia negative. So this is the way machine learning going to help us to predict whether a particular X-ray image is affected with the pneumonia or not. Okay, so this is the execution. Any doubts in this hands-on process? Any doubts in this?
No, sir. No, sir.
Okay, ma'am. Okay, ma'am. Then I'm moving to the summary process. More than 1 billion adults are hospitalized because of the pneumonia. This record is around the world. Again, this is approximation value only. So approximately 50,000 people have died because of this issue. And if these things will be yearly detected, okay, the pneumonia symptom is yearly detected means we are able to avoid the death. one of the main critical things will be experts. The radiologists experts are not available everywhere and always. Okay, some of the experts are in, even we know that, right? Experts is available in Chennai only, in South Tamil Nadu. In Tamil Nadu, we say experts, the radiologist experts are available in Chennai and Coimbatore, not here. Even some of the people are in Madurai, but compared to, say, people are not in remote areas, right? So that is one of the thing. That's why this kind of a model, that model may be a machine learning model or a data deep learning model, which automatically detects the pneumonia from the chest X-ray what we give to that. So even it gives exceeding practices. It gives the exceeding level of an output compared to the practiced radiologist. Okay, so that's all about my topic. If you have any questions, please ask me now.
Sir,
Yes,
Kaggle is only for lung image, or all images are available in that?
all the images is available, ma'am. All the images,
Okay,
not only for lung, ma'am.
okay, okay.
Even some of the data like CSV files will be there, ma'am. Comma separated value files as not only image file, ma'am. It have files as like a text file, CSV file. All the things are available in Kaggle, ma'am.
Okay, sir. Is there any format, sir? Only in JPEG and are all
This
the
image
formats?
is, yes, ma'am. This image is JPEG format only, ma'am. But some of the images which is related to cancer, or some of the images which is related to what that's in different format, ma'am. Available. Those things are also available, ma'am.
Okay, sir. Thank you, sir. Thank you.
Okay, ma'am.
But, okay, sir. Participants, any queries? You can post it in the chat box itself.
Yeah, if you have a doubts, please post it in a chat box. Hello, chat box. Okay, if it is not, I would like to thank you people. Especially, I would like to thanks for the given opportunity. For that, I give my sincere thanks to Dr. V. Jayanti, who is my supervisor. At the same time, I would like to thank Sudha ma'am also for this, for the given opportunity. Thank you, ma'am.
Okay, thank you, sir. Thank you, sir. Shubha, ma'am. Shubha, ma'am. Yes, you carry on, ma'am. Sir, am I audible, sir?
Yes, ma'am. You are audible, ma'am.
Okay, sir.
I guess
Okay.
ma'am may be muted. I guess, ma'am.
Okay, sir. Sir. Okay. It is indeed a great pleasure for me to deliver the vote of thanks. So, on behalf of the Department of Biomedical Engineering, PSNA CET, I would like to thank Dr. C. Rajakumar, who gave a nice talk on the topic of pneumonia prediction. I am sure the participants would be highly benefited from your talk, sir. Thank you, sir. Thank you very much, sir.
Thank you, ma'am.
Thank
Thanks
you.
for everyone for the patient listening. Thank you.
Thank you.
Yeah.
Dear participants, feedback link is given in the chat box. Fill the same within 30 minutes. Okay. And we'll meet you again in tomorrow's session. Thank you at 9:30. Thank you.